So we've got the A500 back on the bench today. I've just powered it up to make sure that it actually still functions and gets to the insert disk screen, which it does. So the repairs. Oh, Rosie, you're going to start in already? Oh, everybody gets to hear you cough. Sorry about Rosie coughing in the background. She's got collapsing trachea, small dog. It's hard, is all I can say, and I apologize for anybody who's distressed by her coughing. Anyhow, it's back on the bench. It came right up. Like I said, we got right to the insert boot disk. So it looks like all the work I've done is at least solid a week after the board's just sitting, which is really nice. But today what we're going to tackle, let me move this out of the way, is this from Retrobench. So I ordered a bunch of stuff out of Europe because I just couldn't find any US or North American dealers selling it. I could have probably just got online and ordered the caps myself, but it was just much easier to just order an A500 capacitor kit. So we've got this little packet of capacitors. We'll open it up and take a look at them. It came with this little instruction sheet that has basically capacitor locations for the A500 and the A500 Plus. And this is adequate to do the job. It should have replacements for all the capacitors. It's interesting to me, I already see that, like with this capacitor right here, the negative signal, or the negative side is on the top, and on my motherboard the negative symbol is actually off to the side. It's 180 degrees opposite this one. So I mentioned that right up front because, keep an eye on the polarity of the caps that are coming out. Make sure the silk screen matches what's coming out. Just because there is a difference here, and it's probably this is Rev 6A and Rev 7. My board is a Rev 5. So there are definitely some differences. Again, that's not unexpected. Let's take a look at the caps. And get the little bag open here. There are extra capacitors in here. This crosses several motherboards. Revisions, and of course any caps that are left over will go into my capacitor stock. These are supposedly high quality capacitors. I'm looking for a manufacturer on them. So I don't know if you can read this or not, where it says 105 degrees C on there. That's a good thing. Regular commercial capacitors are 85 degrees C, so the 105 degrees C says these are, assuming that that's real, are better capacitors. I thought I had read that he supplied Panasonic, but apparently not. I'm not seeing a manufacturer on these, which I'm going to say right up front's a little bit disappointing to me. If those are date codes, these capacitors are over 40 years old. I just don't believe that. Although 100 microfarad, 16 volt. Find that a tad bit concerning. It was $8 for the package, which isn't bad. And it's possible those numbers aren't a date code. Those really didn't seem that old to me. And I really don't recognize the manufacturer. I do see the letters SCFR on a few of them. And maybe that is a... I'm not sure why I thought they were Panasonic. These should be those bulk 3300 microfarad that go up near the video section. Still, it's packaged well. These guys are cyan color, and the two cyans are up here near the video circuit. So, they've done some color coding. That's really nice. It's got a little sticker here. If I can pick it up. that I can stick someplace on the motherboard to indicate when the new capacitors were installed. That's nice. Grab my LCR meter. I'm going to look at a couple of these. I blew the front end out of this on one channel. I don't know if that screen's going to show up or not. It's dusty. So the I think it's 1 kilohertz. Channel doesn't work, and it's set to 1 kilohertz. Oops, it's not what I wanted. Frequency. I'm going to kick it up to 10 kilohertz. And we'll just take a peek at a couple of these and see what we get. Oh, I'm on inductance mode, capacitance mode. Why are you reading negative capacitance? I'm incorrectly polarity-wise. I don't remember the top end for this. Maybe it was the 10 kilohertz range I blew up. The LCR meter's all surface mount inside. So he is a 470 microfarad. This is a frequency issue. At 100 hertz, there we go. You know, he's 470, reading 433. That's not unexpected. I guess I could have looked at the ESR. .9 millifarad, so this is reading 2975 microfarad, which is okay. I haven't putzed with this for a while. Where's my ESR? 0.08 ohms, that to me measures like a good capacitor. A little bit concerned that these aren't, I mean, I would have preferred, you know, Nishikon. There's a couple of real high quality capacitor manufacturers. I think these are 100, these are 1000 microfarad, microfarad. It's reading 948. Again, that's fine. 0.14 ohms. Those look like they're probably fine. I think what I'm leaning towards here is these caps are fine. I'm going to jump over to a different meter here just for a minute because I can. I don't remember volts, ohms. I think I actually have to pull the cap off the paper here if I can get it to release. Downside of this style is this tape. It gets really tight over time. It sticks to the leads. Well, no, this only goes to 40 microfarads, and that's a 100 microfarad cap, or 1000 microfarad, I mean, which is why he couldn't be measured. Let's take one of these little 10 microfarads. Again, I'm more just playing here than anything else. If I can get it to make contact down in there. 9.79. I believe I just said he was a 10, which he is. Actually, we can do the same thing here, just use the .8. Yeah, I'm going to go ahead and use them. I don't think they're going to be worse than what I already have in there, and that these are new. Turn the power off there. These are new. I mean, the ones that are still on the cut tape are new. So they should still be, I mean, they have no operational life on them. They should still be in much better shape than the caps that are on the board that have been, you know, through heating and cooling cycles and have age and use on them. So let me set all these capacitors aside. The other thing I'm going to do here is I'm only going to replace a few capacitors at a time, and then I'm going to power the system up and just make sure I have basic functionality. I highly recommend you don't just swap them all out and then discover it doesn't work, and now you're struggling to find the capacitor that caused the issue. I will probably just go by size. You know, I'll do the two cyan guys here, probably even follow the list here. I'll do the 4 orange ones, and I'll just work through, and then I'm going to connect the system and power it up after every set. That way, if I get like a cap in backwards and it causes issues, or I cause some other issue on the board, it'll make troubleshooting that a bit easier, because I'll know where I was actually doing some rework. So we need to tackle undoing this mod I did over here. We saw it in a previous video where I bent the capacitor lead to replace the lifted trace on the board, and we'll do that as well with the new cap. Hopefully I can get enough heat with this tip to actually release that ground lead. Yeah, there it is. So the ground lead's been released. And we can pull the capacitor leads off the two places it's attached. And there's that cap we kludged in. This is actually a Nishikon cap, which is a real high quality cap. Let me swap over to the good glasses. We will clean out that hole there. I serviced the tool this morning. It's got a new ceramic filter in it. I'm not going to attempt to do this with the hand pump. I'll have to. And of course, now that did clear. So this is, of course, these two guys. I need the full lead length on one of them, on the positive lead, so that I can do the same bend technique we did before to replace that lifted trace. Which is why I'm not just clipping the lead short to get him off of here. So this is the downside of cut tape, is it can be a pain in the ass, especially when it's got some age on it. Of course, that's leaving a fair amount of glue residue behind. So, positive on this guy. This to this side. He's going to have to sit up off the board a bit. How much higher is he going to be than the original? Oh, a fair amount. Hopefully that'll still clear in the case. You know what? I'm 90% sure I just put him in backwards, and I did. Or did I? The negative is on the outside on these two guys. Remember that from before. I guess really that's going to be about it. And hopefully there'll be enough room if I ever get a case for this beast. for him to fit into the case. Positive lead over here. Got a pretty fine tip on here. I may have to go to something bigger because of these large ground pores. I'd really like to see that bubble. Sometimes when the solder gets all the way down through the joint, through the via, you'll see the solder kind of boil. And that's, I've always interpreted that as there's actually air, hot, because it's hot, there's air being drawn up through the solder. And so that's not a bad thing. Not super thrilled with that, but it went in fine. It's just raised up off the board. Not uncommon. Let me get the other guy out of the tape. And this is going to be the same thing where it lays in here on its side. I'll just follow the same process I did before. I'll bend the lead 90 degrees up pretty close to the package. That lead will drop down a little bit below the package. Reach down to this resistor lead. This is actually sitting up where it's going to touch. Those resistor networks. Trying to get an idea of length. This guy will be hot snotted in to provide mechanical relief. He's going to mount up there, and he's going to get bent 90 degrees right about there. A little bit too much lead length on the end here. Trim it back. Little tiny bit more. What I'm concerned with here, yeah, the negative lead should reach down, and I'm going to be able to get that down there and through that hole. Shoot, and of course the lead on this is short enough that it really doesn't want to do what I want it to do. See if I can get a bit more length out of it. Always a challenge. Take the tip of him, bend him down square. Could have actually bent a little bit further back. And that actually gets me a reasonable amount of lead length down through the hole. So I believe we're going to call that good. I'm going to add some solder onto the leads here where they're going to connect to things. Again, this is very much the same thing we did before. set in here, and you're going to get tacked to there. No, didn't hold it long enough. Oh, wonderful! I've got a solder splash here. Doesn't please me. It's going to be a bit of a challenge today, it looks like, doing stuff. Not as pleased with this as I could be. I actually want to get the negative lead soldered here if I can get enough heat from the tip. Get that to flow. It's not a huge ground pour right there. And then I'm going to reheat these other joints, basically to release any stress in the lead where it's moved around. Not quite as happy with that as I was the other cap, but you know, that's going to have to do. A little hot snot will take care of keeping him solid. Let me get that little bit of solder out of here if I can, just so it doesn't flake off at some point and cause. I must have brushed the soldering pencil up against the hybrid array here. And power and video, just to see if it'll wake up. I want to keep, of course, the removed caps separate. Oh, Rosie, you're just having a hard time. That's the floppy cable. That's why I'm confused. It suddenly was too short. Let's see, negative is out, negative is out. Power on. White screen. It takes a bit without a floppy attached to get to the insert floppy, but it should get there. And there it is. So we're still operational. Power supply's off. It's amazing how tight that is. So let's move on to the next caps. Wow, Rosie, you're just having a hard time today. These are going to be these two guys and these two guys, apparently. And those are supposed to be 22 microfarads. Let me take a look at what's already on the board. Rosie, go lay down. You don't need to stand there and watch me. See if I can read these. 22, 22, 22. Okay, they're all 22s, so that's useful. These have got, of course, the leads bend over on them. It's going to need a bit of solder added to it. Just a bit of solder on the tip. It's a big ground plane here. That didn't release. I'm going to have to actually add solder with the pencil. As I've mentioned before, adding solder is your friend. can get it to. That's a large ground pour. Hopefully that'll be enough. So what's happening here is, of course, the positive side is releasing pretty easily. Actually, he completely released. Oh, interesting. The negative. Okay, the silk screen is correct. He didn't release nearly as easily as I would have liked. This guy's just being stubborn. This is the one I had the most trouble getting to heat. Come on, release. There he goes. I think the holes are open reasonable enough to get new capacitors down in there. So these are 22 microfarad. They are the orange caps. There are 5 of them here. In this case, I'm just going to cut them directly away from the tape, because I don't need the long lead length. He is this orientation. And he's 180 degrees out, so he's around this way. Gonna try to hold him somewhat square. Flay the leads out just a bit. And see if we can get enough heat with the pencil. I may have to hot swap the tip here on the pencil for those large ground pours. There's really no thermal relief on those ground pours. Swap out the tip. So the nice thing about the JBC is this tip is already up to temp, just that quick after a hot swap. And that didn't take solder, still didn't get enough heat. Really happy with that either. Wow. Some flux might have helped here. Not pleased with those grounds at all. Not pleased with those grounds at all. It's a lot of copper mass. Hopefully this one will actually work and not explode like the last one did and empty itself out in one. I can hear there's flux in there. I don't remember having to do anything to activate these. Nope. Ah, there's finally flux coming down through the felt tip. I'm just gonna, and that's way too much. Don't know that that's gonna help, but it's not gonna hurt. I'm gonna work my way around the copper. That got a solder joint. Okay. See if I can get enough heat over here. This is a really large ground pour. And it really isn't a good solder joint. We have to come at that from the top of the board. And that's a large copper pour on both sides. And I can feel the lead has been captured by the solder. I'm just not happy with the joint itself. We'll add some solder up here on the top. That's better. We've got two more to remove, which are these two guys. Don't like the fact that the leads have been bent over. Makes it hard to get the desoldering tool up over them. Locate them again. And locate them again, because I keep losing visual on them. In this case, I'm just going to stand the lead up. A bit of fresh solder will help. So as you can see here, patience is important. There's some really fine traces down in here on these, so I don't want to abuse them too bad. I realize a lot of this is happening off camera. Shoot, and yet another bend over lead. Looks like I'm going to add a bit of fresh solder on these. They're pretty dry. His orientation's fine, and he's, yeah, the leads just really bend up. So anyhow, that gets those guys out of the way. We need two more of the 22 microfarads, which are these guys. The silkscreen agreed with the previously installed caps, which is always nice. These guys are in the right orientation. I haven't actually tested the audio on this motherboard. I don't know if it actually works. Don't want the board resting on the caps I'm about to solder. Very fine traces here on these guys. Very fine. It would be really easy to damage this. One solder joint I'm not happy with. Again, I don't know if I've, created an issue in the audio section with this or not. Those guys are in there. The orientation, once again, is correct. Positive to positive, positive to positive. And, once again, the exercise of apply power. Just to make sure we haven't caused an issue. I have a white screen. This takes a second to get to the mount floppy. It's not actually finding a floppy drive to look at. And there it is. So, Workbench 1.3. So anyhow, I'm not going to bore you with going through the rest of these. It'll just be kind of the same process. Working through them a few at a time, testing a few more at a time. And I'll come back once they're all done. So I've worked my way across the board. All of the electrolytic capacitors have been replaced. I did a few at a time, powered up, a few more powered up. I've just replaced the 210 microfarad caps right here. Here's our little sea of capacitors we removed. These are of course all garbage at this point. Got video and power hooked up, and I will do my final power up here just to make sure the system comes up and still seems operational. I have a gray screen, white screen, and that's taking longer. Oh, there it is. So I'm going to pull the camera out of the mount. Apologies for the jerky video. And there we have the boot screen. So pretty happy. So quick final look at the board. Like I say, they've all been replaced, polarity verified. I've got some hot glue to put on over here just to make this mechanically a little better. And I'll call this done.